Hi, welcome. We can complete the section number 3 for sequence, and we have to get limit for the sequence. For this, we can study convergence of sine square n over n. We need to get this limit of this sequence. We know already limit n go to 0 for what? For sine n over n that equal 1. But this n go to 0. We need this limit for x go to infinity and not 0 for sine square n over n. That means if we know that drawing the domain 1 minus 1 and this sine we can draw like this. Then the range positive from 0 to 1. 0 to 1. This positive like this. Then that mean sine n less than 1 and bigger than 0. Then that mean also that modulus. That mean sine square for n less than 1 and bigger than 0. We can get sine 0, sine n less than 1 and bigger than 0 like this. No different. We can over n all size. We can here over n over n over n this square. That mean 0 over n equals 0 less than sine square n over n less than 1 over n. That mean that we need for limit this we can make limit for all size. Then limit n go to infinity for 0 equals 0. Limit for 1 over n go to infinity equals 0. Then the left and size the limit the same. Then this 0 and this is 0. Then the medium this also equal 0. Then the limit n go to infinity for sine square n over n it equal 0. It equal 0. Then the sequence converges to 0. We can see another example number 2. We can have another exercise like what? 2n factorial over n factorial square. We can solve this and find we can get limit for this sequence. Limit n go to infinite for 2n factorial n factorial square that equal 2n. So we solve factorial 2n minus 1 2 and in last factorial n and last factorial n. Then factorial n cancel with factorial n. Then it equal 2n multiply 2n minus 1 multiply 2n minus 2 to last one n plus 1. What this? That mean n multiply n minus 1 n minus 2 2 3 2 to 1. For this reason that equal 2 n 2 n minus 1 2 n minus 2 2 n minus 1 over n minus 1 n minus 2. For this reason we can remove this with this go already, this go. For this reason we can take 2 outside for all times. That times it equal n, that then coming 2 power n multiply, I take this already, then 1 minus 1 over n multiply 1 minus 2 over 2 2 1 plus 1 over 2 divided. We can take also n comment outside, then n we can get 1 minus 1 over n 1 minus 2 over n. This can cancel, all this can cancel about this like this, and all this can cancel also, all this here can cancel, then that equal to this go 0. 1 minus 1 like this, limit n go to infinity, then we can give a 2n 1 minus 0 like that, 1 minus 0 like that, then this 0 and this 0, that mean equal limit n go to infinity for 2 power n, that mean infinite, then no infinite. Okay, thank you. I give 2 examples, this we can enough. Thank you, Mr. Saleh.